Hello, hello. Yes, would like to welcome you back again. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard, once again. We would like to thank you for being with us. We don't take that one for granted. And we would ask you to stay with us. At the end of the day, you are going to realize that this channel is unrivaled by any channel of the sort. Yes, we are learning the dynamics of online presentation. It doesn't come easily, but I want to tell you that, albeit that there is special skills which cannot be underestimated. We are using skills which is close to over 25 years. And we believe that at the end of the day, you will notice that you can't live without this. So don't hesitate to subscribe, because we are going to be relentlessly releasing videos each and every day to help you, to assist you in your endeavor of achieving your goals. So there comes this question. It's in work, energy, and power. Okay, let us analyze the question. We are saying that a 3 kilogram trolley is at rest on a horizontal frictionless surface. So this is the surface we are talking about here. This horizontal surface is frictionless. It is smooth. And the question says, the statement says that a constant force of 10 newtons is applied. This is the 10 newtons we are talking about here. And the question says the force is removed at P. This is the point P. So, in other words, the force was exerted for this distance, and after that it was removed. But while the force is removed, the body continues to move as a result of inertia or momentum. So when the force was removed, the body continued to move, but this time not under the influence of the applied force. So it moved up to Q. There's something you have to take notes of here. We are going to look at it seriously. It reaches maximum height. This is an information which you are going to use somehow. I normally tell people that if you don't have imagination, you can't perform well in mechanics. Mechanics has a way that you have to imagine some situation. So in this case, this statement is very paramount, that if you don't understand it, it might cause problems to you. So a constant friction force of 2 newtons acts on the trolley while the trolley is moving up the incline. So the first question comes. It says, write down the name of non-conservative force acting on the trolley as it moves up the incline. Okay? I want you to remember that on this parameter, we classify forces as conservative and non-conservative in mechanics. For conservative, conservative forces are the type of forces which do work on the body, but they are dependent on the path taken. While non-conservative, they do work on the body, but they are independent of the path taken. I need to remind you that in this topic, mechanics, this one is a clue to help you around. For mechanics, the only conservative force we meet is gravitational force. Yes, there are other forces which are conservative, but they won't be in mechanics. They'll be in other fields. So for mechanics, you have to take note that this is a clue that most of the times, if the question asks for conservative force, for mechanics, the force is gravitational. So for this case, the question is looking for non-conservative. So what is the non-conservative force acting along the incline as the force moves up? The clue is around here. They said a constant friction force. Friction force is non-conservative. So, and that is the answer. The answer is friction force. That is the non-conservative force acting along the incline. Then comes this question, the question 1.2. It says, draw a labeled free body diagram showing all the forces acting on the trolley as it moves along the horizontal surface. So they want us to draw the free body diagram along this horizontal surface. So you have to remember that free body diagram means a diagram without the body, where the dot represents the body. That's why they call it free body diagram. The body is represented by a dot. Then you have also to remember that all the forces on free body diagrams are drawn away from the body, not towards. So let us look at the forces which we are aware of. Now, we have our forces here. The applied force, which is 10 newtons. This force was drawn at the back of the trolley. But you have to know that as for the free body diagram, all the forces are drawn away from the body. And you have to remember in vectors that a vector remains the same as long as it maintains the magnitude and the direction. So force is a vector quantity. So what we are going to do, we are going to take this force and put it in front here. It has not changed anything because it's the same magnitude of force and the direction has been maintained. So that is that. What we have here is our force, or we can call it force applied. So now comes other forces. What are other forces which are acting here? This body is sitting on the ground, exerting its weight on the ground. So what happens is that the weight on this body is acting downwards, and it is given as FG. Then this weight is being counteracted by the force which the ground exerts on the body, and that force acts upwards. Now, the force which the ground exerts on the body, it has a name. We call it normal force. So in this case, I prefer using symbol capital FN for normal force, but there are other symbols which can represent that. Now we ask ourselves, what other forces are there on this body? The answer is, that is all. So this is the free body diagram representing all the forces which are acting on the trolley along our horizontal surface. So at this point, like we always tell you, we are avoiding to make long videos. So we are going to call this one part 1. So we would urge you to go and watch part 2, where we are going to discuss the questions which are following these ones fully. So let us go to the next video, which is part 2 of this question, and we see what comes up.